Thank you. I'll clap for Linda real quick. Let's talk IoT. Many of you know what the Internet of Things is, also known as IoT, but not everybody does. So I want to get a primer and talk to you about what I think makes a good product. So what I'm going to talk about tonight is, what is IoT, the Internet of Things? Why is it important? How should you approach it? I know there's a lot of budding entrepreneurs and engineers out there, and I want to give you a direction when you take your new groundbreaking idea to market. So what is it? IoT is the exchange of information between computational-enabled devices, cloud resources, and digital user interfaces. And that could include traditional mobile apps, all the way now to wearables and voice commands like Alexa. So why is it important? Well, by some estimates, by 2025, it's going to be a $260 billion market. That's big. So how do you get there? How do you get into it? So here's the thesis I want you to go about when you design. The first thing is that devices should be dedicated to performing an essential process or function. Cloud resources are for intelligence and decision-making, and apps are for interface monitoring and control. That's a lot, and it's pretty abstract. So what do I mean? What's a simple way of thinking about it? Well, the way I want you to think about this is your smart device, it should be dumb. It should do one thing. It should do one essential function, whether that's monitoring a temperature, taking in digital input, one thing. It should have one essential function. From there, what you do is all intelligence and decisions should be moved to the cloud. All managing user input, all analytics, all calculations should be done on the cloud, because on the cloud you have vastly amounts more of computational resources. So to better understand that, let's look at the basic architecture of IoT. You have three legs. You have hardware, you have your cloud resources, and you have your apps for interface and control. Three legs: hardware, app, and cloud. But you'll notice that the cloud is the common stop for all your data flows. It's your data broker. It's where you have all of your resources. So let's talk hardware real quick. Now, all hardware has a finite level of resources, and it has to handle overhead. And overhead could be communication, like Wi-Fi, could be settings and parameters and user interface, or process management. But what that means is you have a limited amount of space to handle to your thing, your essential function, what you might call your application layer. And that has consequences, because you might not monitor data as fast, you might not be able as accurate. So what we want to do is try to offload as much as we can to the cloud. And if we take all that we can to the cloud, all of a sudden we now have more resources for our application, our main thing. We have more horsepower to make a higher quality application. We can measure data faster. We can do more things. So let's take a look at like a real life example, what this might look like. So here we have our thing. It's our device. It's doing its one thing and it's doing it well. It's running to parameters A, B, and C. Now this could be anything, but the fact is it's going to do its one thing until told otherwise by the cloud. It's just going to do its one function. Now in this case, the cloud is going to interrupt it with new parameters, X, Y, and Z. Now the new parameters were calculated in the cloud. They could have been user input. They could have been data from another device or from the device itself. But the fact of the matter is X, Y, and Z were calculated on the cloud. The device itself didn't actually do anything. So now the device is going to do its thing, but it's going to do it to X, Y, and Z. And it's going to do its thing well, and it didn't have to think of anything why it's doing X, Y, and Z. It got told by the cloud, and it's doing its thing much better because it has more things to do. So how do we approach this? Well, the first question you should ask is, what is the essence of your device? What's its main purpose? Now, a good way to think about this is, what would your device do if it was offline, if it couldn't get input from the cloud? What would be its default behavior? Once we have the default behavior, the essence, we can break it down into a series of parameters and variables. Like, what are the steps we do? What are the steps we take when we do our main purpose? Do we run for a certain amount of time? Do we run to a certain temperature? But we break it down into steps, essentially. Once you have those steps, variables, and parameters, you can move them to the cloud. And once they're on the cloud, you have so much more horsepower to do things with them. Can you have the user manipulate them? Can you calculate other variables from them? You can make your application better because you've done a lot of this hard work, this overhead on the cloud. And then the final question to ask is, how do you want your user to interface with the device? Because a traditional mobile app is going to look a lot different than a voice-activated app. Now, I want to leave you with an analogy that I like to think about the Internet of Things with. The Internet of Things, you should think about it, is the difference between VHS and Netflix. You're not going to put all of your movies and user settings on a videotape. But what you can do is put all of your movies and all of your settings to the cloud and focus on the one thing you want to do well, and that's play your movie. So when you go out there and build your brand new device, your paradigm-shifting, industry-disrupting device, just remember, don't make your device smart, make it dumb. Thank you.
Thank you very much, Walker. Thank you. All right, coming to the stage right now is Lindsay Gupton. Lindsay is talking about interactive broadcasting, the next mass media.
I like it.